Hello, welcome back. You're watching The Joy of Code, and this is Michael, and today we're going to continue with our Java programming. Today we will actually discuss an entirely new concept, a very important concept that we haven't touched on before, and that is loops. Every programming language has some form of a loop, and usually has multiple different ways to write a loop. What a loop is for is to do one thing many times. It is very common in computer programs that you want to do the same thing over and over again. For example, maybe you write a management system for a library, and you have 2 million books in your library, and you want to do something to every book. You want to, say, update some information. Then you don't want to write that statement to update that information 2 million times in your source code. It is essentially not feasible. You just want to write something that says, do the following 2 million times, update each book. Or you are writing an email client and you want to display the headers of all your messages in your inbox on the screen. And let's say you have 200 messages in your inbox, then you want to show 200 message headers there in a long scrolled list. And you don't want to write 200 statements and say, show this header, show this header, show this header. You just want to say, do the following 200 times. And then just write it once and just write on top of it, this should be done, 20 times, 200 times, however often you need. And that's exactly what a loop is for. A loop is a Java construct that says, do the following statements several times without actually writing them down several times. So we will look at our breakout scenario that we had with the wall with the smoke before by putting some blocks in. So let's have a look at that now. So here's the breakout scenario as we left it last time, almost as we left it last time. The only thing I've done is I've moved the score counter from up here to down there because I want to place some blocks up here now, and that was a bit in the way. So I've just changed the position of my score counter to, it was up here last, now it's down here. This starting version of the breakout project is almost the same as last time, but you can also download it from my blog, and maybe you should download it because one thing I have added is I have added an image for a block. So if you want to put blocks in here, the first is we need a class for a block, which is an actor because it's in the world. So I create a new subclass and I call it block. And that's the one thing here, this block image, block PNG, I have added to this scenario so that you have it available. You can either download this version, breakout 4, from my blog to get this image, or make your own image. So you can just make an image that is somewhat rectangular and looks something like this. So if I do this and I compile it now, if I put a block in here now, it looks like this. And in fact, I've just taken the image of the pedal here and changed the size a bit, made it narrow and higher, and changed the color. So you can make your own block image if you want and put it in, or you can use mine here. It doesn't really matter. So what I want is now I want to write code that essentially creates here a whole row of blocks. So if I do that by hand, I want, say, sort of a row of blocks in here, maybe one more. So I want it to look like this, and then actually I want another row down here and another row down here. So essentially I assume that many of you will have seen breakout games. So there should be these blocks, and then when we play it, at the moment the ball flies right through them, but what we want is that the ball bounces off the blocks then and knocks them out. Today we will just work on creating the first row of blocks. We can of course create a block quite easily. So this creation of the blocks should happen before the game starts. So it is all part of the setup of our game. So we do that in our world constructor. We go to our board class, and here we can see this is where the world gets set up. That set paint order is an instruction that just says I want to always paint the ball on top of the smoke so that not the smoke is on top of the ball. Here the counter gets created, that is this thing, and put in, and then there the pedal gets created, and put in. And actually the pedal itself creates the ball. So that's all there is at the moment. And now I want to create all the blocks. First of all, because there is a bit more involved, it's more than a single statement or so. So I'm making a method for this. So I just say create blocks. It's always good if you have code that is longer than just 1 or 2 lines and is a separate logical function to put it in its own method. And I make this method private because it is not intended to be called from the outside of the world. It's only intended to be called from in here. So it does not have to be accessible from outside our board class. And that's what private means, really. Private means this should only ever be called from inside my own class. So I'm creating that method here. It has no parameters. And I write a comment for it. Okay, so here I go. Let's start slowly. Let's start by creating a single block. That is quite easy. I can say add block, and I can say new block. That creates the actual block. So the new block oops, not a semicolon, because the new block instruction creates the actual block object, and the add block adds it at a location. And we can find out where we want to add it by just creating one by hand. Say I want it here, and then inspect it and see where it is. So at the moment that's at 45 X location and 34. So let's put it somewhere there. Maybe just a little bit higher. Let's say 45 X location and then 30 down. Okay, so if we try that out now, I compile this up. Not add block. I wasn't thinking here. Add object. Of course, the method is called in the world that is inherited from the world class. So let's compile that again. So there is my block. So now I want to have, I forgot how many it was, 6 or 7 blocks across here. What I could do now is to write this method 6 or 7 times, below each other, and work out the coordinates. I could make that work, but that becomes pretty tedious. If I have then multiple row of blocks, at the end I want about 50 blocks on screen. And I would have to write this statement 50 times. That is not a really good thing. So I rather want to do that in a loop. The first loop we will look at is called a while loop, and this is how it is written. There is the keyword while, and then here I have to fill something in which is called a condition. Then comes a bracket open and a bracket closed. Now this is all messed up. The coloring here and the scope coloring is all a bit wrong, because this here is actually not valid Java, my 3 dots here. So let's fix that up properly. So I have keyword while, then in round brackets a condition. Actually let me put that bracket on the next line. It's a bit clearer. You see that this actually looks quite similar to an if statement. If an if statement, there was an if here, then there was a condition. So here we now need to write a condition, and then there was a body, which is a block of statements that was only executed when the condition for the if statement was true. The while statement is quite similar, except that this can be executed over and over and over again as long as the condition is true. So while this condition that I'm going to write here now is true, this will be executed over and over again until it is false, and then we step out of it. So what is my condition? First of all, I don't want to put the blocks all at this location. In fact, what I want to write now in this while loop is create the first row of blocks, just this one row. The row has all the same y coordinates. So the y coordinate, that is this one, the 30, stays the same for all of them. So that should be 30. But the x coordinate should change. The next block should be here, the next block should be here, the next block should be here. So the x coordinate should change. So we need to make that a variable. So we call this x, because that is my x coordinate, and declare a local variable here, int x, for this coordinate. And then we want to, while we create the blocks, increment the x, and when we're at the end, stop. So my first block was at x equals 45. So I initialize this to 45. Then I add the object. Now because x is 45 and I use x here, I'm adding this block at the x coordinate 45. But then when I'm done, after I've added the block, I say x equals x plus, and then I increase it a bit. The width of the block is now important, so I can look at this, I can inspect it, and I see here my block has an image. Let's look at that image. I inspect the image, and I can see that this image, oh, I thought I could see the width of the image here, and I can't. The width of the image is actually not shown in the variable, but I can do that by calling a method. I can inherit it from actor here. I have a... No, I only have a get image. I don't have a... that is not so easy either. I can do the get image here, but I can't see the width. So the easiest is actually then to look at it in my graphics program. So to open this here, go to my images, and here is my block image. There it is, and show the information here, and that shows me my image is 60 by 30 pixels. Okay, that's maybe the quickest way to find out the image size. So the important thing that I wanted to know is the width in pixels of my image. The image is 60 pixels wide. So essentially what I wanted to do here is if I increment my x coordinate by 60, then it will go there. It will move by exactly the width of the image. So the second one will then be exactly next to it. So I want a bit of a gap in between. So actually I want to move it by 60 plus a little bit. And let's say I make that gap a constant. I can create that here. Private static. We have seen constants before. Final int gap, again written in capitals for constants, and I say I have a 20 pixel gap between my blocks. So here I incremented by the width of my block, that was 60, plus the gap. Now if I want to be clever, instead of hard coding the 60 here, I could dynamically find out the width of my block image. I will improve that later. For now, I'll just leave that as it is and keep that in mind as something to be improved, because I've got a number hard-coded here. And if I change the size of my block later, that will not necessarily fit. Okay, so let's look at that again. We start with an x-coordinate being 45, then we add a block at the x-coordinate 45, then we increment the x to be something bigger, and then the while loop here will go around again. Once we reach the end of the while loop, we go to the beginning again, and next time the x is, we have added 60 and our gap, which is 20, so we have added 80. So the next time the x coordinate will be 125, and then we add 80 again, and so on. Now this while loop will twiddle around, and the last thing, the only thing missing now, is to decide at what point we want to stop. Now we want to stop when the x coordinate gets past this point over here. Now let's try to find out where the point over here is. This is the size of our world, so it's 460. So when the x coordinate gets over 460, let's have that as a first try. X over 460, that means then we are out of the world. Then we stop. Oh, that's actually the wrong way written. So this condition is not the condition when we want to stop. It's the condition where we want to continue. We're saying while x is less than 460, which means as long as our x-coordinate is not out of our screen, add an object at the current x-coordinate, and then increase the x-coordinate. And this is a correctly written while loop. So here, what happens as this variable gets created and initialized, we get into the while, the condition is checked, and if the condition is true, the body gets executed, and at the end, we jump back up to the beginning of the while loop, and the condition is evaluated again, and if it is still true, we execute again, and that happens again and again as long as the condition remains true. And when the condition is false, then we jump to the end of the while loop and jump out and end our method here. So the logic is quite similar to an if statement, except that it happens repeatedly. The one thing you have to be really careful when you write a loop is you have to make sure that at some stage this condition becomes false. If it never becomes false, then you have a problem. You will never get out of the loop and your program will just stop working. So let's try this out. And there are the blocks. And now I see this is almost what I want, but this block actually is too far over. And now is the time where we actually have to make our calculations a little bit more accurate. First of all, I want to have my gap a little bit smaller. That's the first thing. I want them, and I want this to be entirely inside. And now, because I have created the gap, defined the gap in a constant, it's quite easy to change it now. If I change my gap to 12, this is what it looks like. This looks already pretty good, except the gap on the left is a bit smaller than the gap on the right. So let's calculate this, exactly what we want. So if we now want to shift the row of these 6 blocks exactly into the middle of my screen, we have to do a little bit of calculation. And that is, first of all, I want to know what the width is of my row. The width of my row is 6 times the width of a block plus 5 times the width of a gap. So let's see whether I can do that in my head. The width of a block was 60 times 6, that's 360 pixels for the blocks, plus 5 times the gap. The gap is 12, so that is another 60. So we get 420 is the width of my row of blocks. 420. My whole row is 460, which means I have space left over for the side bit next to the blocks of 40 pixels, which means I want here a gap on each side of 20 pixels. So I want 20 pixels on each side, and that determines where I want to put my first block. The first block I want to be 20 pixels here from the side. To place it 20 pixels, to have a 20 pixel gap, where do I have to place it? Well, when I place a block, the x-coordinate defines the middle of the block. So here, if I want the middle, if I want a gap of 20 and the block width is 60, then the middle is at x-coordinate 50, because it's 20 gap plus 30, half the width of the block. So here I need to place the first one not at 45 but at 50 and try it out. And now it looks good. So here, this is now the first encounter that we have of a while loop. And the while loop allows us to do a thing repeatedly. So here we have repeatedly created and placed a block. We have a while loop that goes around 6 times, in fact, in our case. And by writing just one add object instruction, we have in fact added 6 objects, because we make that happen 6 times. That's enough for now. That's quite a bit to think about. Loops are incredibly important. You will see loops in programming now all the time. For our breakout game, over the next 2 episodes, we will complete that a bit further. Of course, the 2 obvious next things we want to do is we want to add more rows. We don't want just a single row, we want several rows of blocks. And then we want to make it happen that when the ball hits the blocks, that there is actually something happening. We want the block to disappear when it gets hit by the ball, and that is not happening at the moment. We will do that in one of the next episodes as well. And then we have to fix the scoring. So over the next 2 or 3 episodes, we will complete this game, and we will look a bit more at loops while we're at it. Okay, try this out so far. Download the Breakout version 4 from the blog as a starting point. If you're watching this on YouTube, not on the blog, on the YouTube, in the information under the video is a link to the blog, and there you can get the download of the scenario to start with. Okay, that's it. Until next time.